Hello, good morning everyone. Today we will see the advanced irrigation techniques. These are the constants need for modern irrigation types: macro irrigation, center pivot irrigation system. Conclusion. Okay, why we need modern irrigation technique? To reduce water loss to evaporation. Okay, water loss. To reduce the labor requirement, to use the available water and electricity efficiently and economically. For uniform application of uniform application, uniform application of water. To use available water and electricity efficiently and economically. Okay, available water and this one. So I may ask the question: why need the modern irrigation technique is applied in the irrigation field, but you can write these answers. To rectify the problems in traditional methods, to overcome all these, we have only one solution, that is modern irrigation techniques. These are some types. Previous class also we saw some types, and also micro irrigation, drip irrigation, sprinkler irrigation, forking irrigation, bubbler irrigation, center pivot irrigation. Okay, a micro irrigation system is a modern method of irrigation. In this method, which the deliver water slowly and usually delivered from discrete droplets. Discrete droplets. Okay. Continuous drops. Continuous. In this method, we deliver water slowly, usually delivered in the form of discrete droplets, continuous drop streams, etc. The micro irrigation system is popular these days for it is low cost and water efficiency. Micro irrigation system can increase yields and decrease the water fertilization and labor requirement. Okay, this one. This the fertilization low requirement. Okay, micro irrigation can increase the yield and decrease water fertilization and labor requirement. These are the types of irrigations, types of micro irrigation system: drip irrigation system, sprinkler irrigation system, forking, and bubbler. We will see this in detail of this one. Already I taught one subject about the types of irrigation. So I already sent that PDF. The drip irrigation system, forking irrigation system, sprinkler, and bubble irrigation system. Okay, bubble irrigation system. The drip irrigation is also called as a trickle irrigation. It works by exposing for roots direct supply of water delivered across the field pipes called drip line. So you have to understand this note. Supply of water delivered across the field in the pipes called dripper line. Each dripper limits drops water and fertilizer resulting in uniform application of water nutrients across the entire field. The discharge of the emitter varies from 0.5 to 14 lph. The low discharge of emitter result partial wetting of soil root zone. This one advantages and disadvantages. So I may ask the question: what are the advantages in micro irrigation system, drip irrigation system? So you can try this on water saving, but in the time the initial heavy investment, improved plant growth, investment, weed control, extensive maintenance requirement, no soil erosion, no soil erosion, sanitary hazard, sanitary and hazards, enhanced fertilizer applications, high skill requirement, the advantage, disadvantage. Adaptability application of mulches, the care concern with the lateral. Lateral means that's in slide 1. Minimum decision based problem, rodent problem. The pressurized irrigation method, water is sprayed as resembling rainfall. The spray of water by small orifices or small nozzles. The water serves to pump to pipe network to sprinkler nozzles. The pressure pump helps to rotate nozzle by water. The nozzles are mounted on pressurized pipe systems. The characteristic of sprinkler pipes: flexible, crack and impact proof, durable, uh, sustained pressure. This is the system. Advantage and advantages is minimizing the water loss in conveyance and distribution. No overland flow, maintains soil moisture. No clogging compared with drip irrigation. High water use efficiency. High initial investment. Soil with low infiltration rate cannot be irrigated. High operational cost. High energy requirements. No suitable for crops that require ponding water. Forking irrigation. But semi a forking system used with the purpose of cooling the environment a short period of time, preferred with the aim of ensuring the moisture requirement of the plants, especially in the green. The system reduces indoor temperature greenhouses. In addition, moisture required the plant is provided. In addition, soil is watered by method of moisturizing the air. Advantages: passive collection systems during no energy input to operate. Cheap and easy to maintain and repair. Water quality is generally good. Uh, water quality is generally good. Non-industrial areas through pH can often be low. Disadvantages: the technologies requires very specific climatologic and topographic conditions. Yield is difficult to predict, so through pilot project is required in every cases. Yield is very sensitive to change the climate conditions, and so backup supplies is required. Bubble irrigation. Uh, the bubble irrigation is localized, low pressure solid. The permanent installation system used in tree groves. Each tree has a hose basin which is flooded with the water during irrigation. The water infiltration into soil and widths the root zone. The water is applied through the bubbler. The bubbler flow rates are in the range of 2 gallons per minute. Advantages and disadvantages. Tree bubble improve plant growth. The slower water flow percolates into the soil and into the plant's root zone. This precision leads to healthy plant growth because the strawberry tree-soil landscaped areas are getting the right amount of water at the flow. High initial purchase cost, small water flows cannot. In sandy soil with high infiltration rate, it is difficult to achieve. Okay. Center pivot irrigation. Center pivot irrigation, also called water wheel and circle irrigation, is a method of crop irrigation which is equipment uh, rotates around the pivot. So okay, around a pivot, and crops are watered with a sprinkler. The original and most used style of pivot irrigation applies water in a circular pattern, pivoting around a central point in the middle of field. Almost all crops, including sugarcane, orchard, and vines, as well as more traditional field crops such as maize, potatoes, small grains, alpha, and vegetable crops, can have been successfully irrigated with center pivot water application system under a wide range of conditions. These are some advantages. Center pivot irrigation uses lesser labor than many other surface irrigation methods such as furrow irrigation. It also has lower hose than ground irrigating techniques that require doing clogging channels. Also, center pivot irrigation can reduce the amount of soil tillage. The crop sensitive irrigation system or prone wetting, lack of aeration in the root zone. Wind affects the water distribution. Evaporation losses can be high. Okay, this is the disadvantage. Smart irrigation system buried deep below the soil surface. Soil moisture sensors transmit to the smart irrigation controller how wet or dry the soil is in the root zone, how much water it needs in real time. These sensitive sensors can rate soil moisture within 3% of actual volumetric soil moisture content. Smart irrigation system. Another cloud based modern method of irrigation is mobile apps which put control of smart irrigation system in palm your hand from anywhere. From trim sprinkler system to managing cloud based smart irrigation system on your mobile app. Welcome to the present ever evolving technology driven future modern methods of irrigation. These are some conclusion. The modern irrigation method should be used and promoted because very save lot of water. Modern irrigation methods are also important in increasing the demand food crops. Modern irrigation methods are effective in done in large scale. Okay, these are the uh, advantage and disadvantage. Then another one, water requirement of crops and soil water relationship. Is the introduction. The water balance, the precipitation and PPT means uh, uh, precipitation, evapotranspiration, runoff, surplus. Okay. This one, the irrigation engineers should be acquainted with the type of soil, characteristic of soil, measure quality of irrigation water, frequency of irrigation for proper implementation irrigation system. The factors affecting the water requirement, so water table, climate is an important thing, and you have to study the factor. This one, the intensity of irrigation, type of soil, method of application of water, method of plowing. These are the factors affecting water requirement. Water table. Water table. How to affect this one? Depending upon position of water table to ground surface or much below the water, requirement may be less or more respectively. Okay. Climate. The evaporation loss in hot climate, hence water requirement will be more, and in cold climate water requirements will be less. Type of soil. If the soil is porous, the retention of water is less, therefore water requirement is more. But in clay soils, water requirement is less. Method of plowing. In deep plowing, soil can retain water longer period and water requirement is less. Intensity of irrigation. Intensity of irrigation means ratio of area under cultivation to the total cultivable area. If this intensity more area is cultivation, hence the water requirement is more. Okay, ground slope also affect, and the factors affect the requirement. In steep ground, water flow quickly and find the little sometimes absorb requirement of required amount of water, hence the water requirement is more. For flat slope, water flows slowly, finds enough time for absorbs. Hence water requirement less. Water of application of water. The in surface flow irrigation evaporation is more, and subsurface irrigation evaporation loss is minimum. Hence the water requirement is more in surface irrigation than subsurface irrigation. Definition, some important terms. Gross command area. It is the area which irrigation canals capable of supplying water for irrigation purpose. Uncultivable area. GCA. The area which the agriculture cannot done. Marshly land, barren land, lake, village. Cultivable area. It is area on which crops can be grown satisfactorily. Cultivable command area (CCA). The total area within irrigation project where the cultivation can be alone, crop can be grown. A definition of important terms: cultivable area. It is area where the cultivation has been actually done at present. Cultivable, uncultivable area. The intensity of irrigation. Intensity of irrigation means the ratio of area under cultivation to total cultivable area. If this intensity is more area is under cultivation, hence water requirement is more. Crop ratio is also important term. It is defined as the ratio area to main crop season, so Kharif and Rabi. The crop ratio should be nearly equal. The crop season, the period during the which some particular type of crop can be grown every year in the same land. The Kharif crops. These are the crops. It's called rice, maize, groundnut, millet. They are generally planted in the June and harvested in October. Rice, maize, cotton, and groundnuts are example of Kharif crops. So I may ask the questions. What are the example? Give the crops names for Kharif. So you can write these one. These are four things. Rabi crops. They are generally planted in the November, October, and harvested in April, March. Wheat, barley, pea, and gram are examples of Rabi crops. Okay. The crop which are not included in Kharif and Rabi cotton sugarcane. The definition of some important terms. The crops like vegetable fruits are cultivated by farmers to sell in the market to the meet the current financial requirements and they called cash crops. So you know the cash crops. The crop rotation. The process of types of crops to be grown in the same field as known the crop rotation. It has been found in same crop is grown in same land. Every year fertility of the land gets diminished and crop production is reduced. The necessary salt required by same crop for growth is exhausted. If crop rotation is adopted, fertility of the soil is restored. Rice, gram, wheat, millet, gram, rice, gram, wheat. This is the 3-year crop rotation. So root, bulb, fruit, seed, this one. The definition of important terms, crop period. It is the period required by a crop from time of sowing on the time of harvesting. Overlap allowance. Sometimes the crop of one season may overlap the next crop season by few days. During period of irrigation, water is to be supplied simultaneously crop of both seasons. This provision is termed as overlap allowance. The ratio of number of days canals has actually been kept open to the number of days canal was designed to remain open during the base period. The factor number of days canal practically open, no number of days the canal designed to keep open. Okay. The capacity, these are some definition important terms in this, the crop requirements. Capacity factor, generally canal designed for a maximum discharge capacity, but actually it is not required by that time. The average discharge to the maximum discharge is as capacity factor. The number of watering, the total depth of water required by crops is not supplied at one time but is supplied over base period. The initial watering to the land before some crop is known as plio or pleva. The first watering is done, crop has grown 3 centimeter. Known as core watering, the period is known as core period. Cubic day, the quantity of water is flowing continuously for one day, the rate of 1 meter cube per second. 1 cubic meter is equal to, so this is an important thing. So 8.64 hectare meter. Arid regions, the area where rainfall is very rare and occurs irregularly and where the agriculture is not at all possible. This is the period of first to last watering of the crop just before its maturity. Delta is important term. You have to study this one. Important, huh? Yeah, delta. Right, about this, you have the calculation part also. Base period delta. Uh, delta this one. Duty this one also important part. You need to study more. It is the total definition you should know. Okay. It is a total irrigated by a unit discharge running continuously during the base period and its unit is area cubic. Thus, duty gives relationship between the volume of water and area of the crop which it is measured. Okay. The factors affecting duty. So you have to know the uh, duty means it's a total area irrigated by unit discharge running the continuously during the base period. So you have to know what's the meaning of the base period. Period from first to last watering. So you have to clear cut idea about the base at the delta. Next delta, the depth of the total amount of water supply. Okay, right. The factors affecting duty, the soil characteristic, climatic conditions, the rainfall, base period, type of crop, topography and agricultural land, method of plowing, method of irrigation, water tax, methods of improving duty, proper plowing, method of supplying water, canal lining, transmission loss, crop rotation, implementation of tax. Methods of improving duty. In the factor affecting duty may be made less effective. Duty of water may be improved. Thus, the methods of improving duty are suitable and efficient method of applying water to crop should be used. The canal should be lined to reduce seepage loss. Water should be conveyed quickly to reduce evaporation loss. Idle length of the canal should be reduced. Construction parallel canals to run side by side FSL. FSL means full supply of water in dam. So or that's canal. Is reduced to minimize the loss. Methods of improving duty, the proper plowed, the leveled crops and improves the duty. Improves the duty. The source of supply should provide good quality of water. Crop rotation, if practiced, improves duty. Volumetric assessment of water with water tax compels the farmers for economic use of water which improves duty. The farmers must be trained to apply correct quantity of water at right time. Maintenance of irrigation project from headworks to the end of canal by administrative should be adequate. The relation between duty base B delta, duty of an cubic, base period of cropping days, delta is depth of the meter. Number one, cubic the water running continuously for a period of days provides volume of this one. Amount of water required flood with the depth. Relation between duty based, hence the area in the can be irrigated by 1 meter cube running for base period B days. Dt is equal to B into 24 into 60 60. Okay, 10 power 8.64 B divided by delta. The problem, so up to this level you study this one. I will explain later this problem. Okay, we will see next part, balance portion.